Hi guys, in this video we are going to learn how to rearrange the equation to minimize the error we are getting. So you may have a doubt whether we can reduce the error if we change that equation, if you format that equation in another way. What are you thinking about that? Please pause the video and comment it below. I hope you have put the comment now. So most probably you will think that the error won't change because these are going to give the same value. So why we are going to get an error? But the thing is actually we are learning in this series that approximation, we need to use approximation when you are using calculators. So when the calculator cannot have the infinite number of digits in the number, it's going to approximate that value. So if the approximation happens in these types of equation, it's going to return a value of 0 like that. So what's going to happen is if we get a value of 0, the calculation may go wrong. So let's see an example first of all. So actually we knew that if x is equals to 0, it's going to be 1 minus sec 0 divided by tan squared 0. So we knew that sec 0 is going to be 1. So 1 minus 1 is going to be 0 and tan squared 0 is also going to 0. So it's going to be a huge infinite number like that. So let's take an example that value is going near to 0. Let's say 0.01 degree. So if we use that, what's going to happen? Let's see what's going to happen. So x is equals to 0.01 degrees. So I'm going to use the calculator for getting the answer. So I'm going to write 1 minus. You can also do that. It's going to be 1 minus 1 divided by cos 0.01. So I'm getting the answer of 0.00000015. I hope I'm correct. 0, 0, 1, 2, 3, 4, 5, 6, 7. Yes, there are 7 zeros and 1 5. So likewise, I'm going to calculate the value for tan squared 0.01 now. So it's 1.74 into 10 to the power minus 4. So I'm going to square it. It's 3.046. So I'm going to write it correctly. 3.046 into 10 to the power minus 8. So actually we have already learned from that approximation the calculator cannot store whole digits in a decimal number. So what is going to, let's say we are having a calculator which is using 4-digit chopping for approximation. So when we give this type of equation, let's say 1 minus sec 0.01, what it will do is it's going to cut off from this point. Only it will take the 4 digits. Likewise, if we change this in the normalization decimal point form, it's going to return the value of 0.00000003, I think. So let's say it's 0.46. So it's going to cut out from this point, chop it off. So here what we are getting is 0 divided by 0. So when we are using the calculator, it might return a very big number, or it might tell you have inputted incorrect math input. So when is the decimal number, when we are using the approximation, it's going to get wrong. So that's why what we can do is we can change this equation in a format where we are not getting these kind of problems, these kind of zeros over there. So how to do that? So we are going to use the trigonometrical function to change this format where we can cancel out this 1 minus sec as well as tan x. In these scenarios, if tan x, when we are calculating, if x is greater than, very much greater than 0, we can actually use this equation. It won't get a problem, it won't cause a problem for us. So here we are going to change these formats. So we need to change, first of all, we need to change the 1 minus sec x part, and after that we need to change the tan x part. So how to change that? So please pause the video and try to new own. So okay, let's try that. So 1 minus sec x divided by tan squared x. Actually, we have already learned from trigonometry, we can easily multiply it by 1 plus sec x in both sides. So 1 minus sec x, 1 plus sec x, tan squared x. So here 1 plus sec x. So here in the above part, we can write it like 1 minus sec squared x divided by tan squared x, 1 plus sec x. So we can change it off. For this part, it's going to be it's going to be minus tan squared x divided by tan squared x into 1 plus sec x. Let's say we are not calculating for 0 values, so x is not the 0. So what we can do is, so I'm going to delete this part. So what I'm going to do is, I'm going to chop it off that tan squared x, so I'm going to get minus 1 divided by 1 plus sec x. So here, as you can see over here, if let's calculate this value and find it out what's going to be the answer. So now we are having minus 1 over there divided by 1 plus the sec x. If we find the value of sec 0.01, we are going to get an answer of 1.0000000015. So here you will be getting a doubt whether this answer is correct, because we are going to, in this case also, we are going to cut off by the digit 4. So sorry, 4. If we cut it off by 4, we need to change, first of all, we need to change it for normalized form. And after that, we need to cut it down in the 4th decimal. So it's going to return, it's going to approximate in this value too. But whether we are getting the correct answer, that's the question. So minus 1 divided by 1 plus, here it's into 10. So we are going to get finally 0.10000 into 10, which means it's going to be 1. So if you simplify this, we are going to get minus half, which means minus 0.5. So here, even though we are having that approximation, we can get a correct value when x is very near to 0. So that's the idea. So the thing is, we can't use this equation for all the time for getting the correct approximation in all cases. It won't be true. But here we have considered the values for x is very near to 0. So in this case, we are going, if we use this type of equation, we have already, we use this equation, if we use this equation, since it might get 0, we are going to get an error. So that's why for this value only, for finding a correct approximation for this value, we have changed that equation. We are not getting any more 0. So likewise, we have solved the problem. So you can also find whether this equation can be used for every situation. So let's say if sec x becoming minus 1. So in any other case, let's say sec x is near to minus 1. If we are using sec x near to minus 1, in those cases, we can't directly use this equation. It might get wrong. It might get very much. So it depends. So always, it doesn't mean this we can use this equation for every time, but rather than using this equation for x, the values of x which is near to 0, we can actually change that for this point so that we can get a clear estimation. Always remember, if we use that infinite digit in our calculator, we are not going to get an error. But here comes the problem. We can't use that storage. It's limited storage. That's why actually it would be useful if we can simplify, if we can use another way, if we format that equation and use it in another way. I hope you have understood this concept clearly. In the next video, we are going to learn another problem which is similar to this. So I hope you can easily understand that too. Thank you for watching.